In this video, we're going to look at what redshift is, and also at what the Big Bang was, which are both pretty complicated topics. The central idea is that from Earth, every direction that we look into space, the galaxies seem to be moving further and further away from us. Or in other words, the universe is expanding. As we'll see, the main evidence for this is the red shifting of light from distant galaxies, while the explanation for why the universe is expanding lies in the Big Bang theory. To understand redshift, we first need to understand absorption spectra. This box here shows the absorption spectra for visible light that's emitted from the Sun and observed here on Earth. On the left, we have the longer red wavelengths of light, and on the right, we have the shorter purple wavelengths. Now, all of the wavelengths here are emitted from the Sun towards Earth. But the Sun's atmosphere contains lots of different chemicals, and some of them can absorb certain wavelengths of light. For example, oxygen molecules might have absorbed these wavelengths, hydrogen might have absorbed these ones, and various other chemicals will have absorbed other ones as well. This means that when the light reaches Earth, certain wavelengths are missing, and the absorption spectra for visible light ends up with a pattern of dark lines, like we can see on our spectra. When we analyze light from distant galaxies, though, we find that their spectra look more like this, with the black lines in exactly the same pattern, but all shifted towards the red end of the spectrum. We call this process redshift, and it happens because all of the light waves get stretched as they make their way towards the Earth. So if one of these gaps was at a wavelength of 600 nanometers, by the time it got to the Earth, it might appear to be at 650 nanometers in our spectra, because all of the wavelengths and the gaps have been stretched and so appear shifted towards the red end. The simple explanation for this is that the distant galaxies which are emitting the light are moving away from us, and so while the waves are travelling towards us, they get stretched. The complicated bit, though, is that the galaxies themselves aren't moving away from us by travelling through space, but rather the space itself, that's between us and the distant galaxies, is expanding. And so because the space between us gets bigger, we end up being further away from the galaxies. We can model this by imagining a balloon that's covered in little markers, with the balloon representing the universe, and the markers representing all of the galaxies. As we blow up the balloon, which represents the universe expanding, the galaxies all get further apart. But importantly, this happens because the space between them gets stretched, rather than any of the individual markers moving across the surface of the balloon. So if we were this central galaxy, it would look like all of these other galaxies were moving away from us, when in reality it's just a space in between that's expanded. Another important point is that the further away from us a particular galaxy is, the more quickly it will appear to be moving away. So it's the most distant galaxies that will be moving away from us fastest. Now, whenever you're working with models like this, you have to remember that models aren't perfect. For example, in this model, one limitation is that balloons only stretch so far until they burst, whereas the real universe isn't likely to burst. And also, if this was meant to represent the universe, then there should be galaxies inside the balloon, rather than just on its surface. Despite all of these limitations, though, we still use models because they help us to understand difficult concepts, which can otherwise be kind of hard to understand. The last thing we need to look at is how the universe began. If the universe is currently expanding, then it makes sense that in the past the universe was smaller. And if we continue this line of reasoning, then at some point the universe must have been tiny. So the question really is, how does a tiny thing suddenly expand to become a huge, ever-expanding universe? The honest answer is that we don't know, but we have some pretty good ideas. And a generally accepted idea is the Big Bang Theory. This proposes that initially all the matter in the universe occupied a really tiny space, which was unimaginably dense and hot. Then all of a sudden it exploded, and space itself started to expand, which is still continuing to this day.